I'm Stuart Strickland. I'm the wireless CTO at HPE Aruba Networking, and I'm here with my colleague Jeff Weaver, who unfortunately is probably not going to be able to join me on the stage today, but is here to take questions. Um, we want to share with you some of our thinking around private cellular network, how that's related to Wi-Fi networking, and why we think that this is an important opportunity for enterprises, and why we've taken some of the steps that you've just heard alluded to. So let me talk with you about how we see these as technologies, what some of the feedback we've gotten over the last couple of years from customers are about what specifically they want to do with them, and then why we think this is the right moment to make that happen from a couple of different perspectives, from the perspective of spectrum availability, from the perspective of some new and emerging use cases, and also what specifically Aruba can do to make this a digestible, scalable, easy to manage system for our enterprise customers. So I think this diagram has been floating around for a while, and I'm going to show you a little. So typically, there's that completely symmetrical spider diagram of what wonderful things 5G can do as opposed to LTE, and then this sort of awkward diagram of areas of strength of Wi-Fi. And so what this masks, so we think Wi-Fi is still by far the best technology for a very dense, high capacity indoor network. But there are some specific areas that a 5G system, or really a cellular system generally, can bring. And it's not in the millimeter wave area. So 25 gigahertz and that sort of neighborhood is not where we're talking about running private 5G networks. We're talking about running them in the mid-band. And in the mid-band, in the United States, that will typically be sub 3 gigahertz, or sub 4 gigahertz. The areas of strength are in wide area coverage and in high-speed mobility and handovers, and in determinism, really. And we believe that we're at a critical point in the availability of shared spectrum in that range that we can offer a complementary product of Wi-Fi and 5G. Over the past couple of years, we've been working with a number of customers in the United States to kick the tires on CBRS-based systems, which operate obviously in shared spectrum. And we've determined that there are 5 or 6 areas where there are specific capabilities that they're looking for. Now, I'm not going to describe these as use cases. I describe them as drivers or capabilities because they can be used for a variety of different things. One of the most common is to get wider area coverage outdoors, wider area than Wi-Fi can typically get. And that's because it's awkward to put in nodes of the networks in, say, the middle of an airfield, or because it's just more costly to do that with Wi-Fi than it is with a cellular network. What we also see is a specific client applications emerging that require more deterministic behavior. And often this is determinist, these two are linked, determinism and high velocity mobility, where, for example, a customer might have a roller coaster that's sending back telemetry data, or it might have an AGV running through a warehouse, typically moving at velocities that are much faster than Wi-Fi was designed for. So if there's a handover event, what happens is not entirely deterministic in terms of maintaining continuity of the connections. Also, in many warehouses, there are challenging and dynamic RF environments that Wi-Fi sometimes struggles with. In many publicly accessible private enterprises, say retail, hospitality, hospitals, there's a need to segregate back of house traffic from publicly facing traffic, from the sort of the visitor traffic that comes in. And trying to do that over Wi-Fi can be challenging because you have only so many bands and devices are competing with the clients on an equal status of infrastructure for airtime. And being able to cordon off, whether it's a stadium or a hospital, the critical back of house employee-to-employee communication, device-to-controller communication from visitors who are coming in and just casually using the network, or maybe even intensely using the network, watching Netflix while they're in the waiting room of the hospital, it's important to be able to keep that traffic separate. And then finally, and this is a use case that's been suggested for private cellular networks for a while, but hasn't really been widely realized, the use of a private cellular network to fill indoor cellular coverage gaps, to use it as a neutral host network to provide access for public network subscribers who move into a space where there is very limited public cellular coverage. And all of those are real problems that customers have come to us trying to solve. That customers don't come to us saying, I want to use 5G, tell me how I can use it. Customers saying, I'm using a Wi-Fi network, I'm trying to accomplish this, I'm having trouble with it, can you fix it somehow? We try to work with them. First answer would always be, yes, we absolutely can find a way to make Wi-Fi solve your problem, but that's not always true. And I think especially as we start to move forward and see more of these use cases, Wi-Fi as a technology is trying to solve the problems of a very wide constituency of consumer devices, of client devices, of infrastructure devices, and it's not realistic to expect that enterprises using that technology are going to be fully in control of the air interface and of the medium. That it was designed as a technology in which peers interact to figure out what resources are free. Cellular is a technology that was designed for the network to be in control of the resources and to assign those resources to client devices. And that's what we're trying to take advantage of. We would not be doing this if it weren't for the availability of shared spectrum. There are really two things that we think are critical to a wide-scale adoption of private cellular networks among enterprises. And one of those is that the enterprise be able to be in complete control of the network that's operating on their premises. And the only way that's going to happen is if they're using spectrum that is already identified as available for their exclusive use, and not spectrum that they have to sublicense from or borrow from a mobile network operator. When our customers come to us and they say, we want a private cellular network, their emphasis is really not on we want cellular rather than Wi-Fi. Often it's we want a private network rather than an operator-managed network. So our task is to figure out how to make that happen. One of the ways to make that happen is through the availability of the spectrum. So our focus is going to be on mid-band spectrum that's currently or soon available in those countries and in these frequencies. But the second component is to make it easily digestible to them. So the way that I have characterized this, and I realize that this is a bit optimistic, that the deployment of a private cellular network should be as easy as taking an access point and adding it as another node on your Wi-Fi network. So we should be able to take a 5G G node B, plug it into an Ethernet port somewhere on your facility, for it to show up in the same management tools, in our case Aruba Central, that you use to manage your Wi-Fi network, and for everything to be visible and controllable through that interface. And that's where we that's where we want to go. I want to talk a little bit, before I talk about how we make that happen, about the neutral host use case. And I think some of you have seen from our past work on Aruba AirPass that we had been promoting the idea of using Wi-Fi as a neutral host platform for onboarding cellular devices in areas where cellular coverage is lacking. We've been running that as a pilot now for about 3 or 4 years, and we found that it is overwhelmingly advantageous to both enterprises and mobile networks. And the issue that we have, though, in that situation is that Wi-Fi there's a rivalry. There's always going to be a rivalry between Wi-Fi and cellular when you're talking to mobile network operators, and that's sometimes an obstacle in terms of getting them to go along with offloading or roaming onto a Wi-Fi network. And globally, outside of the United States, very few operators support Passpoint, and so very few operators can take advantage of that. Our hypothesis is that by using a native cellular technology, this will become not a technical question, but just a business question about whether or not operators want access to a footprint that they did not themselves invest in, but that enterprises invested in. And we found that enterprises are very interested in this because there's really no other good way to solve their cellular coverage problem. So we have this neutral host model already established within Wi-Fi. We've been running it as a trial for a couple of years. And it's a relatively small scale trial. We've only got 20 customers involved in it, but it's about 1,300 sites. And we're carrying a really remarkable amount of data for that site. So this is really just a proof that there's an appetite for doing neutral host. And our view is that this is a potentially untapped driver for a private cellular deployment in the enterprise space. And that we can support that natively through interfaces that already exist in the 5G architecture, as shown over here on the right. So all of the European operators, for example, who prefer to interact with this sort of system, the way they roam onto each other's networks, can get through that way. You may have noticed recently there was an announcement from Meta that they had a relationship with the US operators using a MOCN gateway, that architecture would also be supported. We have a lot of different options here, and a lot more options than we had with the Wi-Fi network. So let me tell you about how we imagine an Aruba portfolio unfolding around private cellular offerings and how those interact with Wi-Fi. So first of all, I should say that we do not imagine a case where Wi-Fi networks are going to go away and be replaced by cellular. And we're not really interested in going after greenfield applications where there's no network today and we're going to put in a fresh 5G network in isolation. That's not where we see we can have our strength. We have our strength in areas where our customers, Aruba customers, have already deployed a Wi-Fi network and are looking to augment that. But with our past partnership with Cellular, we had a kind of network in a box that allowed customers to evaluate what a cellular network can do, but it was never going to be integrated with Wi-Fi, and that's still an option. If you have a use case that you don't want to see integrated with Wi-Fi, but you just want to be easily deployed, you can get that. There is a division of HPE which offers a core network to mobile network operators, and that is still going to be available. That's not, neither of those are really part of the story that we're telling today or that's new. What's new is that we integrate the management system of the Wi-Fi network and the 5G core so that they are, in the cliche, a single pane of glass. And so that it becomes as easy to deploy an additional cellular node as it is to deploy a Wi-Fi node. And then that over time, as we develop roaming agreements with operators, that we can augment those networks as neutral host networks. Architecturally, where we are in a kind of conceptual roadmap, I should say this is not a product roadmap where I'm going to tell you what we're actually going to add in what sequence and in what time frame, but conceptually, what's missing now and what do we need to add. You can think of the cellular network as this column on your left with various different components in it, lacking a neutral host capability, lacking integration with the Wi-Fi network, and a Wi-Fi network over in the right-hand column, which has, in our case, Aruba Central managing that network and radios on the ground. Over time, what we need to add to that to get where we want to go is, first of all, to align the identities between the two systems. Because one of the most striking differences between Wi-Fi and cellular is that Wi-Fi uses various different credentials in order to authenticate you on the network. The cellular network uses a SIM card. The Wi-Fi network allows you to assign roles based on an individual user. The cellular network identifies a device and allows access based on the identity of the device. We need to align those so that there's a mapping between devices that have gotten onto the network with their SIM credentials and users who are known to the venue. And that's going to be, in fact, the technology that we've used to support the neutral host system of Passpoint, onboarding devices with cellular credentials to the Wi-Fi network, is the foundation of that unification. And then beyond that, so I mentioned that from the perspective of the network manager, these systems need to be easy to manage and integrated, but also from the perspective of the client device. We expect that there will be overlapping, but probably not completely overlapping coverage areas between cellular and Wi-Fi. For example, a device may be in a warehouse on the Wi-Fi network, go outside to a rail yard or something and be on the cellular network and move back and forth between them. We need to make sure that there's sufficient information shared between those two networks to anticipate handover events between Wi-Fi and cellular, and also to make sure that regardless of the radio network that you're on, whether you're on the Wi-Fi network or you're on the cellular network, you can still get access to the same local edge resources. So there's a data path available from both legs into the same resources, whether those are local resources or in the cloud. And then I guess at one point I skipped this higher level up here of the integrated management service. You should see that as having essentially two flavors. For those customers who manage their own networks through Aruba Central, that's the interface of Aruba Central. For customers who have Wi-Fi as a managed service, that is part of the managed service. So where we want to end up in the end is basically this sort of environment where you've got Wi-Fi nodes, you've got private cellular nodes, you've got clients that are some of them dedicated to one network or the other, you've got clients that have come in from outside and on board to one network or the other, and you've got clients that move back and forth between them. Regardless of which side they're on, they're able to get access to local resources, compute and data resources, and that they are managed through a cloud management system that offers Aruba Central as its portal to the network administrator.
Your neutral host, your experience with the Wi-Fi offloading, tying into that, how close will the private 5G follow that same model? Kind of not, because the Wi-Fi is the whole carrier takes it right to the edge.
Yeah, so in the Wi-Fi model, the Wi-Fi network and resources are under control of the private enterprise completely. The operator has made no investment in that. The participation of the operator is that they've signed a roaming agreement with HPE, and that extends to our customer base. To that extent, it's the same model. The enterprise will have invested in the private cellular deployment, and we will have a roaming agreement with the operator. We have some additional technical requirements for each of them that are a little bit different in terms of how the authentication traffic is managed, how the data plane is managed. In the MOCN model, user plane traffic goes back home to the mobile network operator, whereas in the Wi-Fi model, it's all locally broken out. But it's essentially an extension of the same model. From our point of view and why we think it's going to be easier to scale, it's the fact that we don't have to persuade any stakeholders within the mobile network operators that it's just as good as their RAN, because it's essentially the same technology as their RAN.
If I was an enterprise and I wanted to turn on that, sorry to stay on the neutral host, because that's kind of a bugaboo. If I rolled this out to my network, the neutral host would have to be truly neutral. AT&T, Verizon.
All operators, and presume, but in principle, any non-US operator as well. Yeah.
Would this continue to be through HPE, your agreements?
Yeah. Yeah. So one of the reasons for doing the agreements in the first place was having the ability to extend them to cover multiple technologies. So the idea is that a roaming agreement that we have based on Wi-Fi with relatively little revision can be extended to support whatever radio technology is on the ground at an enterprise. Yeah.
Do you foresee some sort of premium AP down the road that's everything?
Oh, I'm so glad you asked that question. Yeah, so there's been a lot of internal discussion about that. Some of it more thoughtful than others. I think that there's a spectrum of views on this. Some people think it's inevitable and say, oh, it's a hybrid device, they're hybrid cars, therefore there will be hybrid APs that are 5G and Wi-Fi. Some of it's a little bit more sophisticated. In fact, in my previous life, I came to HPE from Qualcomm, and one of the things I was responsible there for was the idea of an integrated Wi-Fi and cellular chipset. And it never really got traction. And I think one of the fundamental reasons why it didn't, and why I'm still skeptical, is that the design cycles of the cellular roadmap, 3GPP update rates, are not really well aligned with the design cycles of Wi-Fi. And there's a fundamental difference in the philosophy of 3GPP and Wi-Fi. With 3GPP, every generation we start with a clean slate. We can do whatever we want, and we have no obligation to bring old clients along with us. With Wi-Fi, we have to support every Wi-Fi device over every generation that has ever been created, and we even decided to do that with the 6 gigahertz opening up, even though we had an opportunity for a greenfield. And that is a lot of weight to carry, but it also means that our customers can upgrade their infrastructure whenever they want to, confident that they don't have to upgrade their client base at the same time, that they can do that in preparation of future changes in the client base, or they can do that in preparation of some of their old IoT devices continuing to run indefinitely. So when they make their upgrade decisions, that's based on what they need and what the tax code says about depreciation and all sorts of other things. If those two pieces of equipment were in one box, then you would have to align the client side and the network side in a way that would make it awkward to upgrade in as orderly a way as we can. It would be much more like, what are the cellular companies going to do when they finally turn off 3G? And we don't want our enterprise customers to be in that situation. The other issue is that part of this outdoor coverage model and wide area coverage is that we're not going to have completely overlapping coverage areas of Wi-Fi and cellular. And you stick a device that has Wi-Fi and cellular in it out somewhere beyond the range of Wi-Fi coverage, what's the point of that, right, from your other nodes? So keeping those as separate pieces of equipment, I think, is going to persist for some time. Also, in the near term, although we make hardware and the software management systems for Wi-Fi, our ambition at the moment is to focus our attention on where we think we can make the most difference, and that is to integrate the core network of the cellular system with the, I'm going to call it core network of Wi-Fi, and to continue to support the standards-based interfaces to multiple different radio choices. Whether that would change in the long term, I can't say yet, but I think it's important for us to know our limitations and to focus on the area where we can make the most difference. And right now, there are a lot of choices on the radio, and the radios are not very well differentiated from each other, and that's a tough business to run. And I don't think we need to be in that business in order to successfully introduce this into the existing install base of Aruba equipment.
Did you?
Good. Sort of extending that question a little bit. The devices, the end user devices, can potentially have multiple radios in them.
Yes, and I think most of them
and
will.
then,
Yeah.
So that will be the roaming issues as we roam between these different environments. How do you see that working? And as we roll out the 5G core network, does a Wi-Fi device then have access to the same services that you can get on a 5G network when it roams indoors because there's a 5G core network on the network?
Yeah, so it should have access. Well, I'll answer the last part first. Ideally, the device that's on the Wi-Fi network would have access to all the same stuff and features and everything that they had on the cellular network. But of course, there are some limitations and reasons why you put the cellular network in place. And so, for example, the high-speed handover that I referred to might not be accessible, but maybe they've had to slow down because they're indoors, so that's not so critical. There will be some differences, but in principle, the core resources, capabilities, features, data should be aligned with each other. So device, we do expect that most of the devices that are deployed in these environments that have both radio technologies will be capable of both of operating in both, and that mobility becomes a real issue. This is an issue that we saw already with inbound roaming of cellular devices onto the Wi-Fi network. We have a lot of information about characteristics of the Wi-Fi network that could be shared with the cellular network to make that handover or mobility generally a more satisfying experience, like where's the perimeter of coverage of the Wi-Fi network, what's the quality of service on the Wi-Fi network, what's the current load on the Wi-Fi network, information that's routinely exchanged between nodes of the cellular network. I've made several attempts to make that information available to our mobile network operator partners. Sometimes they even ask for it. I see no evidence that they've ever actually opened the files or read them. And it would really be cumbersome for them to try to digest them into a public cellular network. I started a group within the Wireless Broadband Alliance for, I can't even remember what it was called, for access. It's still running, I no longer chair it, for access network, quality of service, exchange of information. It's not as verbose as that. But the idea was, let's identify the information that's known to the Wi-Fi network that would be useful to the cellular network to improve continuity of service and mobility. There's a lot of information there, and there are some very well established transport mechanisms to share that information. It's going to be a long time before that's shared between private networks and public cellular networks, but we can do that right away in sharing between a private cellular and a private Wi-Fi network. And that's part of the work that we have to do for ourselves. A lot of it's not, that's beyond what's in any standard. The work going on in 3GPP and in IEEE doesn't really cross over enough to create that kind of bridge. But industry, if it has an interest in offering the two together, can come up with proprietary solutions. So I expect that's what we'll do.
How do you handle the inherent problem that Wi-Fi decisions are made by the client and cellular decisions are made by the infrastructure?
Yeah, so
that's fairly different.
That actually that's one of the things that's driving us to want to have a cellular leg on the system. That ideally, many of our enterprise customers would prefer that all decisions are made by the infrastructure. It's not entirely the case that that infrastructure makes it for cellular and clients make it for Wi-Fi. The clients and the infrastructure negotiated in Wi-Fi in a way that the infrastructure has no real advantage and can predetermine.
Nicely coding around the outside of the truth is the client still makes it.
The clients make a lot of decisions. We try to influence those decisions. Sometimes we were successful, right? And we would like that to be a more deterministic process, which I don't see that ever really happening in Wi-Fi, because in IEEE, there are a lot of interests, and there are a lot of interests on the client side. And it's a different dynamic in 3GPP. And we want to take advantage of that as well. So that is always going to be a gap between the two of them. And so some of, as we were speaking about just a moment ago, some of the quality of service capabilities that we will have deployed private cellular in order to meet will not be available on the Wi-Fi leg of the system. That's just how it is.
Yeah. So we have a lot of tools at our disposal for troubleshooting wireless, Wi-Fi specifically. What do you see and envision from a 5G?
Yeah, so this is the part in which I'm sorry that Jeff had to leave, because it's his area of specialization, and I think we're going to have a lot of work on the ground at the deployment level of radio network planning and troubleshooting. And as much as there are parts of the Aruba Central system that will be about controlling and changing the system, there will also be a lot of monitoring and collection of data. And honestly, I think that's going to be an open-ended experiment for us. I think we will discover a lot of things about private cellular networks that the operators don't even know about deployment, sure, yeah, because we will be deploying them much more densely than they have experience in doing. But I agree completely, that's going to be an important area of innovation and of learning, and one that we're really looking forward to.
I was just wondering, in the keynote presentation, Sylvia asked a question about, will Wi-Fi or will private 5G kill Wi-Fi?
Yeah.
And then Phil kind of cautioned, be careful how you answer this question. So it kind of seemed at at layer 8 that there was some uncertainty on which technology would dominate or win, or how they fit together. So is that kind of a play, or is there still some?
No, I don't think. Well, I don't think that's going to happen. And I don't think that anyone who's seriously involved in developing this roadmap believes that one of them is going to dominate the other. Wi-Fi is currently the overwhelmingly dominant incumbent, but it has some gaps and weaknesses that we need to augment and fill. I don't think it's not like the story that Kareem told about the decline of the Republic of Venice. 5G is not the oceanic voyaging vessel that's going to eclipse the Mediterranean-bound sea ships. That we don't foresee that at all. But we do foresee a heterogeneous network environment in which both of these things need to figure out how they're going to work together.
I was just kind of surprised I didn't see security called out up there. I know there's sort of inherent security in the SIM cellular sort of interaction, but I do think you guys Aruba has an interesting opportunity when you have the structure that you have to really take this type of security to another level, right? And with the whole integrated network story and all of that. So I just kind of surprised I didn't see it up there.
Yeah, so that's right. And I think that's an important element of the story that I haven't focused on today. But I think often when Wi-Fi is pitted against 5G, it's suggested that 5G is somehow inherently significantly more secure. And I don't think that that's the case at all, which is one of the reasons why it's sort of skirt around it. But there are nuances and levels of control in the Wi-Fi security story that we have in a lot of our products that are simply absent from the 5G security story, because you basically have one class of user who's your subscriber, and you want to let them on and keep track of them and let other, and keep that cordoned off. With I think in the private environment, there's going to be an expectation that there's a lot more differentiation, segregation, nuance, differentiated access, even among a single SIM device, and we'll have to bring that to bear on the private cellular network as well.
Because you're targeting like the most critical devices in most of these use cases, right? Like it's the low latency, high speed vehicles, it's the autonomous
right,
stuff.
the ones that really have to really work,
Yeah.
right?